Have a lab session by one of our students, and the topic will be image captioning using twin transformer. So over to you, Aryan.
Good morning, all of you. Myself, Arun Maisri, and I am going to assist you through ML model, machine learning model. And I am going to share my screen. अच्छा, तो हमारा बेसिक ऑब्जेक्टिव क्या है? हमें इमेज कैप्शनिंग जनरेटर एक मॉडल बनाना है यूजिंग ट्रांसफॉर्मर। और ट्रांसफॉर्मर वैसे तो CNN के बाद का, CNN सबसे पुराना मॉडल है, ट्रांसफॉर्मर उसके बाद का है, यानी कि एनहांस्ड मॉडल है ट्रांसफॉर्मर। तो ट्रांसफॉर्मर क्या होता है? बेसिकली ट्रांसफॉर्मर डीप लर्निंग मॉडल है, आर्किटेक्चर है, जिसमें हम नेचुरल लैंग्वेज प्रोसेसिंग जैसे कि मशीन ट्रांसलेशन हो गया, टेक्स्ट का समराइजेशन हो गया, इन सब का यूज कर सकते हैं। अब हम ट्रांसफॉर्मर को लाए क्यों हैं? पहले क्या होता था, RNN जो मॉडल यूज होता था वो बहुत स्लो होता था और टाइम कंज्यूमिंग होता था, और साथ साथ स्टोरेज कंज्यूमिंग होता था। तो उसकी जगह हम एक ट्रांसफॉर्म बेसिक मॉडल लाए जिसमें हमारा पूरा एक, हम उसको टेक्स्ट प्रोवाइड कराएंगे उसको, या इमेज प्रोवाइड कराएंगे उसको, फिर बाद में वो तोड़ देगा किसमें, अलग अलग फीचर्स वेक्टर्स में। एंड पोजिशनल एम्बेडिंग, ये सब बेसिक स्ट्रक्चर है ट्रांसफॉर्मर का। एंड हमारी मेथडोलॉजी क्या है? सबसे पहले हम डाटा को प्री प्रोसेस कराएंगे, उसके बाद मॉडल का आर्किटेक्चर डिफाइन कराएंगे, फिर उस मॉडल की हम ट्रेनिंग कराएंगे। एंड ट्रेनिंग के बाद हम उसका इन्फ्लुएंस, यानी कि एक VLU स्कोर होता है, अगर VLU स्कोर 0.6 से 0.7 आता है तो वो हमारा, यानी कि मॉडल बहुत अच्छा वर्क कर रहा है। और अगर 0.5 टू 0.6 है तो एवरेज वर्क कर रहा है हमारा मॉडल। VLU स्कोर बेसिकली होता क्या है? बाइलिंगुअल अप्रोक्स में अंडर स्कोर होता है, जिससे हम एक मॉडल को दूसरे मॉडल से कंपैरिजन करते हैं इन द इमेज कैप्शनिंग जनरेशन। तो बेसिकली हम सबसे पहले लाइब्रेरी सेटअप कराएंगे। फर्स्टली वी आर गोइंग टू सेटअप लाइब्रेरीज। We have to import OS library and import NumPy, and following, and name it as NP. Matplotlib, that is used to represent the graphs in our model. And PyPlot, Keras. Keras is used in neural network. TensorFlow is also used in neural network models. Okay. अब हमें सबसे पहले, फर्स्टली वी हैव टू import the data set in our Kaggle library. So we have to work on Flickr 30K data set. So firstly we go to add input and search for Flickr 30K. As you have seen that there is already present there, and we just add it, and Flickr 30K is ready to use. You can see it there, and our data set is already in our Kaggle library. There is like mostly images that are used for image captioning. Okay, and we have a small file caption.txt in which a description of each image is given. Now we have to give the image path. So we have to copy the image path from there and put it here in the image path variable, and caption path also, the path of caption.txt file we have to put there in caption path variable. A default size of each image is 299 and comma 299. Means in transformer we have the 300 times 300 299 into 299 image size, which we have to divide it into smaller patches, and then these patches will be used for the image captioning further. And we set the epoch number of epoch small as 3. If it is larger, then our model will be trained efficiently and will improve the result of accuracy. So we have to run this one, stop the session and start a new one. Okay. Our draft session is starting and takes some time. Okay. Basically, we have used the accelerator in our Kaggle library, Kaggle environment, that is GPU P100, which is very fast, that are freely provided by Kaggle, and run and import all the libraries one by one. It is successfully run, and we have to pre-process the data. It is also done successfully. Now, one by one, we have to load the caption that we have seen in caption.txt file to our basic model. So there is a defined load caption data, a function that is used to load each image caption one by one, or line in caption data. Each image is repeated 5 times. Yeah, basically each image have the 5 caption as you seen 10. This is the image, and we have 5 given captions, and we have this is the image. Okay, this is the image, and there is 5 caption given for that image. Two young guys with shaggy hair look at their hand while hanging out in the yard. As you can see, it is same. Two two guys are hanging in the yard. Yeah. Okay. And each image has 5 captions. As you can see, one image have 5 caption. 1, 2, 3, 4, 5. And we move forward. Each caption is loaded into the model. So we have to run this, which is successfully run. As you can see, total number of samples are 26,144, and number of training samples. So we have divided the total samples into two: training samples, validation sample, and test samples. So training samples are 20,950, validation samples are 5,124, and test samples are 105, which we have to test on that. Now we have to define the vectorizer with custom standardization and image augmentation. The custom standardization means we have to, if there is any space, as you can see, there is a comma in the caption, there is a double colon in caption. We have to remove all these. So it convert it into the custom standardization. We define the custom standardization function here, and vectorization for tokens, as we have tell already that we have to provide the images into tokens to embedding function, and then this token will forward आगे बढ़ेंगे, ये मतलब आगे will forward. Okay. And by running this, as you can see, there is no error. As you can see that we have used keras and its function sequential for the randomization, data augmentation, all these. Now we have to visualize the sum of the images with corresponding caption. And as we can see that we have to load images in another window and caption in another window as this one. So we have to visualize both of them in one place. So we have defined visualization function. As we can see that this is the image and there are 5 captions for that image. A man and little girl is splashing in a pool. And for this image, a person in red sitting on a beach. As you can see, there is a person sitting on a beach. People enjoy the sandy beach near the water with a funny looking tree on the beach. So these are the 5 captions for each images, and we have at the start and end sequence using the custom standardization function. Now we will find the caption length. Each caption has some length and their histogram chart for caption length. As we can see that maximum length of each caption is a maximum up to 12,000 frequencies, and the 15 is maximum length, means 15 words are maximum. As we can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 words in this caption. So this histogram tells about the caption length. Now we have to determine the word occurrence of each caption, which is run successfully. Okay. Now we have to data setup for model input. Okay. As we can see that there is a start and end sequence at the prefix and suffix of each sentence, and we have to replace it. As we have used replace function here, start mean if there is a colon or a comma, then we have to replace it with start. And if there is a comma at last, we have to replace it with at. Okay. Now data setup for model input. Now we have to set data for the model input. We have, uh, firstly, we have to process each image one by one. As we defined the image path previously as a variable and set the image path. So it is the input for this function, decode and resize. If there are different size of images available at, so we have to resize it equally using this function and return the image one by one. And this function is used for process input, and means one by one we have to process the input and decode and resize each images and apply the vectorization which we have defined earlier in this one. Vectorization, text vectorization, number of input unit tokens in transformer, as we can see. Okay, and make data set. Means if with each images there is a caption, so we define the make dataset function, and input our images and caption. This is run successfully. Now we have to train the dataset. As we can see, there is a shape 299 comma 299 comma 3. So 3 is basically this refers to the RGB image. uh, you can see there is a image which is a black and white or RGB. So we have the input feature for RGB, and 299 comma 299 is the size of the input image. Now we have to define the image captioning model. So we use the transformer efficient net V0. It is a family efficient net V0. We have efficient net V0, V1, V2, V3, V4, V5, V6, and V7. Up to V7, we have the efficient net V0 family, and we have used the efficient net V0 because it is the fastest and uh, best for picture extraction model. Now we use the encoder embed feature, image feature. We use encoder, decoder as earlier we have encoder, this one, and we have decoder. So in, in the image captioning model, we have defined encoder and decoder, and output is dense layer plus softmax function activation function. Softmax activation function basically describe the output of each caption. If there is a if 0 and 1, two are the outputs for softmax activation function, which define the probability of each word in the caption. Okay, so we run the CNN model. Okay, so we have transformer encoder black, in which we have used the layers, which is encoder class of the transformer, and in transformer we have given uh, function. Okay, multi-head attention model and a layer normalization layer attention layer, in which we have multi-head attention layer norm. We have layer normalization, layer norm 2, we have layer normalization again. So basically in transformer we have attention layer, and we have layer normalize, for which we use layer normalization to normalize the layer in our transformer, and positional embedding at the each word. Means if you have uh, let me tell, let's say we have this image. Okay, this image have 5 captions. So positional embedding works as a we add each word. Means we add a man with this image, as you can see. Okay, I am going to share you some. As you can see, this is our transformer model. So we have input image, and we divided into patches. This input image is divided into patches, and then we flatten and reshape this image, and then patch embedding. Each image will be tokenized into a patch embedding. Then what will position embedding do? Position embedding will add add the word with each patch, and then we have encoder and then decoder, which provide our output. Okay, so this is the basically work of positional embedding. Mm, okay. So positional embedding class used transformer for adding each word with each patches. Now transformer decoder. Trans Now transformer will use its decoder block class to decode each passage with each word. So we use here also attention layer, which is multi-head attention, and in which we have provided the num heads in input and key dimensional as embedded dimensional, which we have earlier initialized in our data pre-processing. Okay. Now we have dense layer. Dense layer in is also available in BGG16 model, and it is also in a transformer for feature extraction. Dense layer will work as a extract the feature of each image and add the add the word with each patches. Okay. Now we will define call function, which we have to call it. Now image captioning model. Here, whatever we have defined earlier, whatever the function, call function, whatever the class function, we have to use in image captioning model class for run for training the model. Okay. As we can see in CNN input size is CNN model input shape, which is 299, 299. CNN output shape is also 299, 299, which we have to divided by two patches. Then encoder input is dense layer and shape, which is output shape. And as we have earlier defined the embed dimension and set the value for this variable in data preprocessing. Continue for and we have defined the calculate loss. Means we have to calculate the loss, calculate the accuracy. These are the functions: compute caption loss and accuracy, and train step. It is where our model will train, which batch loss 0 and batch accuracy 0. Okay. There is a for loop for iterating through each epoch. That we have set the size for epoch 3. Okay. Now as we have described the get CNN model of function. So we call it here and encoder, decoder, and capture length. These are the variable in which we have stored the function that we have defined earlier here. As we can see, transformer decoder block, transformer encoder block, all of these things. So we have to run this. Okay. So it is successfully run. As we can see, CNN input save, which we have described 299, 299, output save with 81, 500, which is average, and encoder input dense layer save, which is 81, 512, and decoder. There are two input for decoder. One is caption and one is embed image features, which uh, which will work and give us the output with each image. Mean if we give one image, then it will provide us a image its caption. Now we have to train the model. First, we have defined the loss function. In Keras library, we have losses class in which we have sparse categorical quotient trophy, in which we have to give two input as a first one is boolean and another one is we can say none. Yeah. Now, as you can see, we have three epoch, and each each epoch will take approx 5 minute timing. As we can see, our loss is heavy here, 37 point, and it will decrease one by one with each epoch, and accuracy will increase as there are 30,000 images there, and 20,000 are for training. After after the training function, we will plot the training and validation graph here. Okay, so there will be there time for the epoch. We can also increase the accuracy by increasing number of epoch. Basically, by default, we have 15 epoch for the best accuracy. Now come to the inference point. What will inference do? There are caption generation. At each time step, the decoder takes as input the embedded images, picture along with decoded caption that are started with start at the first time step, predicting the probability of the next word. Caption generation predict the next word probability and give us give to image. And for that we have greedy algorithm. Greedy algorithm will choose the greedily will choose the probability with greedily and provide us caption. As we have the VLU score. Yeah, evaluation is performed using VLU score and visualization. The function visualization plots the images along with their actual and predicted caption. Our images will look like this. Okay, this one. As we can see that we have provided the image, then generated caption. A woman in a black dress is walking down. Okay, down the street, and we received four VLU score. VLU 1, which is 0.3098, which is worst. VLU 2, which is 0.55, which is average, and VLU 3, 0.7036, which is a more than average, and we have received 0.74, which is best in image captioning model. Our training model ran similarly. Uh, for caption generator, we have used the vectorization class in which a get vocabulary function used with sequence length that we have defined earlier, uh, and a greedy algorithm function which with input image. Okay, and this function will generate the caption and store in set. Okay, each generated caption will stored in set and will with each key value pair. There is a key value pair in set. We all know that, and with each key is referred to image and value will refer to caption. Okay, with each key there will be a value. Mean with each caption there will be a cap. With each image there will be a caption in the generated caption set. And we have defined the VLU score, and we can as we have defined VLU1, VLU2, VLU3, VLU4. So we define the VLU1 here, VLU V1, V2, V3, and V4. Okay, that will be written by this function VLU score. Now, for now, if a caption is generated, it is easy task. But for converting each caption into the audio, yeah, it will request a great. It will be a unique way for image captioning model. We use the GTTS, which is a library from Google, and use its API for converting each caption into audio. Okay, and for that import NumPy, Matplotlib, that we have also imported earlier, GTTS. GTTS refers to Google Text to Speech library, and define the visualization with speech function, in which each caption will be transformed into audio. Okay. First we get the VLE score, then load and display the image, then display the caption with the scores, and then convert the caption to speech using GTTS API or library. We can see. Then we will plot using Matplotlib library. So it is further, yeah, we done approx 2 epoch at a time. And then we have given the caption length, word occurrences, and all for this. First, we have to wait for each epoch to be run. Um, as we can see, there are 3 epoch, and approx time is 275 seconds for each epoch, and there is a last one that are and estimated time is 3 minutes. And we can see that loss from 22.3 to 39 comes to 17, and accuracy also increases. If there is a large number for epoch, as we can see 15, then accuracy will be high for the generated caption. But in this transformer, we have to evaluate the accuracy using VLU score. Highest VLU score provide the best caption for our image. As we can see, our epoch is running and GPU is heavily used, which is provided by the Kaggle as an accelerator. We can use TPU also, but in TPU environment, we have to install some libraries, extra libraries. So refer to GPU P100 for running this. We can also input another data set from there, as we have worked on Flickr 30K. Okay, there is also a Flickr 8K data set that is used for image captioning. Okay, we can also put it in our Java library. We can see Flickr 8K image captioning website. Then, okay, all epoch have successfully run. Now we will plot it. It takes time for save the model. Okay, so it is continuously running. Okay, it's successfully run, and we can see that we have three epoch, and trend versus validation graph is there. Okay, now we will use the vocab for vectorization and generate the caption. Correction. Okay, there is JavaScript, nothing to do with it. If we run it on Colab, then this error, this JavaScript error will not be shown. We are running it on Kaggle. It takes time. Some we can cancel it. Okay, we can run it again. It will take time. There is a GUI here, graphical interface here, that will show each caption one by one. So there will be a JavaScript in Kaggle, but not in Colab. It is still running. Okay, it's successfully run. Now we will run this shell. Now we will install GTTS, which is Google Library. Now, sir, ये बोलना इसमें टेंशन है. Now we will run this cell. Okay, as we can see, we have provided 4 images, and there is a caption that is generated, and we can see there is a group of 4 people are sitting on a bench. Yeah, we can see we have a smaller epoch, so, and we have a value score 0.78 for this. Okay, and the a young boy in a blue shirt and blue jeans. Okay, a baseball player, as we can see from baseball player, and each caption we have provided a audio, audio, yes, yeah. So it is successfully run. Okay, and if we have to caption length histogram, we have this maximum frequency is 17.5 and maximum caption for this is 18. This is histogram for caption length. Yeah, all this is thank you for attention. Thank you all of you.
Okay, participants will end this session right here, and we'll share this notebook for you to practice more. If anyone have any query, they can ask right now.